In pro-
Hello, Math 2, grade 7 students. Now we are now in this last chapter of our lesson in science. We are talking about water. It's topic 9.1, surface water and groundwater. Why do you think floods occur? Now, surface water is the water that collects on the surface of the earth. This includes seas, oceans, streams, lakes, canals, and swamps. I want you to see this water or global water distribution that 97% is ocean, 2.2% is ice, 0.7% is groundwater, and less than 0.1% is fresh water. So the seas and oceans are salt water. They have a high content of salts. Streams, lakes, and canals are fresh water that contains very little or no salt. Fresh water is extremely important to sustain the lives of all living things on land. When it rains or snows, some of it falls into the seas and some falls on the ground. Some of the water is absorbed by plants and some evaporates into the air. Some seeps into the soil. The excess water that is not absorbed by the surrounding area is known as runoff. Runoff flows across the surface into nearby streams, canals, ponds, or swamps. Here's amazing facts. Streams that are steep and fast flowing are usually narrow and shallow. Streams that are slow flowing are usually wider and deeper. Interesting. What about groundwater? Groundwater is the water beneath the surface of the ground in the zone of saturation. In this zone, the space between soil particles is saturated with water. You see in the picture? So this is impermeable stones and zone saturation here. Above the zone of saturation is the zone of aeration. In this zone, the space between soil particles is filled with both air and water. You see here the soil moisture. The water table is the boundary between these two layers. The level of the water table changes over time due to the changes in water cycle and precipitation pattern, stream flow, and geological changes and even human activities. This is water table. Now, the groundwater comes from rain and snow. The water seeps into the soil and moves down until it reaches the impermeable layer. There it is stored as groundwater. The soil helps filter and clean the water, and therefore, groundwater is often considered clean. Now, look at the picture here. Groundwater and surface water are connected in most places. All right. So, groundwater and surface water can trade places. Why is that? Groundwater can move through the ground into lakes or streams. Surface water can soak into the ground and become groundwater. When it is dry, more groundwater is pumped out to meet the demand for water. When there is abundance of rainfall, groundwater will replenish itself. Most of the groundwater is clean, but it can get contaminated from leaky underground tanks that store gasoline, leaky landfills, or excess fertilizers and pesticides used in plantations. Now let's talk about the science at work. A spring is a location where groundwater naturally emerges from the Earth's surface. It can discharge fresh groundwater either onto the surface, into riverbeds, or into the sea. Uses of groundwater, I should say, uses of water and water management. Freshwater and groundwater are consumed by living things for survival. We also use water for irrigation, washing and cleaning, generating electricity, and cooling equipment and machines. Now, we need to conserve water, both surface water and groundwater. It does not only reduce our water bills, but also lessens the environmental impact, such as water pollution and the cost for treating water. We should wash vegetables in basins instead under a running tap. We should wash only full loads of clothes in washing machines. We should take a shower instead of soaking in tubs. And we should fix dripping taps. And we should collect rainwater to water plants and to wash car porches. And we should use bucket to wash the car instead of a hose. Besides that, in the bigger scale, we can collect rainwater in reservoirs and catchment areas. This will help protect against flooding too. We can also collect and treat wastewater for industry use. Although there is plenty of seawater, we cannot use seawater as it contains salt. By building desalination plants, the salt can be removed, and this helps solve many water insecurity issues in the world. However, this process is very expensive. Watch this video on YouTube about groundwater. So, what is groundwater? Watch.
We all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer. There are huge aquifers all across America. The biggest is the High Plains Aquifer, which covers 174,000 square miles right in the middle of the country. Anything that big deserves a closer look. Let's say you could grab a shovel and dig straight down through the soils to an aquifer. The level underground where you first hit groundwater is called the water table. Below the water table, the ground is completely soaked or saturated with water, which is why this area is called the saturated zone. The area above the water table is called the unsaturated zone. So, how does all this water end up in the ground? Well, it's all a part of the good old water cycle. When it rains, some water gets soaked up by plants. Some water runs off the soil and into streams, lakes, or even the ocean. Other water gets stuck on the surface and eventually evaporates back into the air. Meanwhile, some of the lucky water droplets get to travel down through the surface deep underground until they reach the water table and become a part of an aquifer. Once water seeps down deep enough into the ground, it can stay there for a really long time. Some of the water stored in the deepest parts of aquifers has been there for thousands of years. But after it gets there, groundwater doesn't always stay in the ground. A lot of the water on the surface comes from aquifers. If the surface of the ground dips below the water table, groundwater flows out into the space, creating a body of surface water. If the surface water dries up, groundwater can flow in to fill it back up. And if the water table in this area rises, so does the level of the surface water. Groundwater can also pour down a sloping surface, creating streams. Any place where groundwater flows out into the surface is called a spring. Surface water can also become groundwater. If a body of surface water flows above the water table, water can seep down through the sediment and help fill the aquifer. Of course, there's another way that groundwater can leave the ground: us. Humans depend on groundwater, and there are thousands of wells all over the country that draw water out of aquifers. In many parts of the country, the water you get from the tap comes from the ground. However, we use most of our groundwater to help grow the food we eat. Farms can get lots of the water they need from rain, but rain isn't always enough. And in dry years, farmers depend even more on the water that's stored in the ground. In fact, American farms use about 53 billion gallons of groundwater every day. That's enough to fill over 1 million bathtubs or 80,000 Olympic-sized swimming pools. So, if we're using that much every day, can it run out? Well, yes and no. Remember, aquifers can be refilled by rainwater or surface water seeping in from rivers and streams, so there's usually more water on its way to replenish the aquifer. But if we use groundwater faster than the aquifers can refill, we could drain them dry. They probably wouldn't be empty forever, but it would take hundreds of years for the largest aquifers to get back to healthy levels. Whether it's up here or down there, water and how we use it matters. We may not be able to see it every day, but groundwater makes our lives possible. So don't let show-offs like rushing rivers and roaring oceans get all the attention. Those unseen aquifers below ground have been here longer than we have, and with a little love and care, they'll keep on taking care of us long into the future.
Alrighty, information from U.S. Geological Survey. Now that you have watched it, let's go to the Earth's water. What about the Earth's water? We have seen already the groundwater. What about the Earth's water? Watch. So on December 7, 1972, astronauts on board Apollo 17 photographed the Earth from space. Look at this video from the NASA. The vast expanse of water they saw earned the planet the nickname the Blue Marble. "71% of the Earth's surface is covered in water. This water can be found in all three states of matter. We have the solid or the ice, we have liquid right there in the ocean and in any other forms or places, just like rainwater or tap water. In gas, you see in the air, That is also water in that state, gaseous state. So they're up in the clouds, you see water. Water can be found in most places in, on, and above Earth. Water is found in bodies of water like oceans, lakes, and rivers. Water is also found in living things like plants and animals. Water found in atmosphere as clouds and fog. And in solid form as snow and ice. Most of the water on Earth is round or is found in the oceans. The oceans contain about 96.5% of the Earth's water. Another 0.9% of the Earth's water is from other saline sources such as groundwater. The remaining 2.5% of the Earth's water is fresh water. A little over 2/3 of the Earth's fresh water is locked up in glaciers and ice caps. 30.1% of fresh water is found underground. Only 1.2% of all the fresh water is from surface and other liquid sources. Clouds, like marshes, like what else? You see around like rivers and lake, right? What about the rain? Okay? In soil moisture, there is water there too. Snow and permafrost. Living things. Well, there is water everywhere. Well, you can find this one in geography realm. Now that you have watched it, well, I want you to look at this conclusion. Surface water is the water that collects on the surface of the earth, such as the water in the rivers, oceans, and lakes. Oceans and seas contain salt. Lakes and rivers contain very little or no salt. Some rainwater that falls on the earth is absorbed by plants. Some evaporates into the air and some seeps into the soil. Some flows into rivers and lakes. Groundwater is the water beneath the ground in the zone saturation. In this zone, the soil particles are soaked in water. Above the zone of saturation, there is the zone of aeration, whereby there are water and air in the soil. The water table is a boundary between the zone of aeration and the zone of saturation. We use both the surface water and the groundwater for many purposes. An appropriate and suitable water management is needed. We need to save and conserve water so that we will have clean water in the future. I want you to go and turn your book to page 165. Check how much you understand this subtopic by doing Test Yourself 9.1. Answer all the questions. I'll be waiting and come to me for more points. Okay, see you in the next video. Bye bye.